Alright, we're going to do simplifying radicals and the number I. And I have no idea why my learning target's not here. Okay, our learning target is I can simplify radicals. There we go. Alright. So, if you hate this lesson, you have to get mad at this heartbreaker right here. This is Rene Descartes. He is the reason we're doing this, because for some reason he was really mad that you couldn't take the square root of a negative number, so he invented this thing called imaginary numbers. You'll also hear these called complex numbers. I've heard people call them magic numbers. Please never say that. That sounds awful, and that's not what they're called. So, imaginary numbers. Okay, so here's the things you need to know. Equations such as x squared plus 1 equals 0 have no real solution. So mathematicians define the imaginary numbers to represent their solutions. So this is Rene Descartes' fault. Okay, so the imaginary unit, we use I, and it does have the little fancy swoop. And I can't remember why that is. But if you go into like physics and stuff, this is used a lot in electricity, but they use a J. But in our class, it's called an I. Okay, anyways. So it's defined as I is equal to the square root of negative 1, always. This is useful when working with square roots of negative numbers. So there's these things called pure imaginary numbers, and they're written in the form bi, where b is a real number and I is the imaginary part. That's not that useful, but I just wanted to show you in the calculator why you'll see like an A and a B. So this is where they're getting B from. So a big deal in mathematics, but you may never use it. Okay, so here's some weird stuff. Your calculator is automatically going to be in real mode. Anytime you reset the calculator, if you're one of those people who clears the memory after you do everything, it's going to automatically go back into real mode. So you must put it in imaginary mode when using imaginary numbers. So if you're in real mode and you type in the square root of negative 9, you get an error message. If you're in imaginary mode and you type in the square root of negative 9, you get 3i. This is what you want to happen. Okay, so you cannot use Desmos to do this. These can only be done if you're using the calculator. They can only be done in like a TI-84 calculator. But it's okay because I want to show you how to do it by hand. But if you do have a calculator, you'll hit the mode button, and then real is usually going to be highlighted, but this A plus BI is called imaginary mode. And that BI is what we just talked about. So it looks weird, but anytime you want to put it in imaginary mode, A plus BI has to be highlighted when you go to the mode button. Okay. Ooh, that's a really blurry picture, sorry. You can enter the number I in the calculator, and you can hit the second button, and then, it's really blurry, I'm sorry, but right above the decimal button, you'll see like a little blue eye. So, let me say that. You're going to hit the second button and then the decimal button. And if you forget that, you can always go to your catalog, and it's right there in the eyes. Okay, so you do not need a calculator for this because here's what we're going to do. Anytime you're going to simplify a negative square root, you're going to rewrite a negative number like this. So I'm going to rewrite the square root of negative 4 as negative 1 times 4. So I hope you can see what I did. Actually, I'm going to do it backwards, because I think it makes more sense. So every time we do this, I'm going to do the positive number times negative 1. Okay, so what I'm going to do is I'm going to separate this. This is 4 and negative 1. Okay, so Rene Descartes came up with a number for this. Anytime you see the square root of negative 1, you change it to an I. And we already know what the square root of 4 is. The square root of 4 is 2. And remember that anytime you take a square root, you have a positive and a negative answer. So my final answer, if I simplify the square root of negative 4, it's going to be plus or minus 2i. The number I always goes behind a whole number, but it will go in front of a radical. And I'll show you what I'm talking about in just a minute. So the answer is going to be plus or minus 2i. Okay. So look at number 2. I'm going to rewrite the square root of 9 as the square root of 9 times negative 1. And now I'm just going to break these apart so I can see them a little bit better. The square root of 9 is 3, and anytime you take a square root, you do positive and negative. And then Rene Descartes said the square root of negative 1 is I. So my final answer is plus or minus 3i. Alright, number 3 works the same way. I'm going to rewrite it as 196 times negative 1, and then I'm going to break it apart. The square root of 196 is 14. And remember, anytime you take a square root, it's an understood plus or minus. And the square root of negative 1 is I, so my final answer is plus or minus 14i. Okay. So now let's look at these. So you're going to see that the square root of 80 and the square root of 32 are not perfect squares. So we're going to have to simplify them a little bit different. Okay, I'm still going to write it as positive 80 times negative 1, and I'm still going to break it up like this. Okay, and still, the square root of negative 1 is going to be I. Now I just have to deal with that square root of 80. So remember, if it's not a perfect square, we want to find the biggest perfect squares divisible by. And if you need to write out the perfect squares, you can. That's 1, 4, 9, 16, 25, 36, 49, blah, blah, blah. The biggest perfect square that 80 is divisible by is 16 and 5. Okay, so I rewrote the square root of 80 as the square root of 16 times the square root of 5. So now I know that the square root of 16 is 4, and anytime I take a radical, it's plus and minus. The square root of 5 is a prime number, so it's going to stay the square root of 5. And then I is going to be in the middle, because the I will go behind a whole number, but in front of a radical. It's just kind of like grammar for math. That's just how it's written. Okay, let's do number 5. Same thing. We're going to break this up into positive 32. I'm just going to go ahead and start doing this. And negative 1. Now, I know what the square root of negative 1 is. It's I. 32 is not a perfect square, so I'm going to find the biggest perfect square that is divisible by. I can break up 32 as 16 and 2. Alright, so the square root of 16 is 4, understood plus and minus. The square root of 2 is a prime number, and then that fancy little I goes in between. Alright, moving on. I want you to try this one, and then we're going to work on solving some equations. So go ahead and pause the video in 1, 2, 3. Okay, so square root of negative 1 becomes I. The biggest perfect square 192 is divisible by is 64. So the square root of 64 plus and minus 8, square root of 3 stays square root of 3, and I goes in the middle. So if that doesn't make sense, stop what you're doing right now and send me a message. Okay. So now we're going to solve some equations, okay? Because up until now, when you've done these and you got that the square root of a negative was inside, you would put no solutions. We don't ever do that. We're always going to have solutions for quadratics. Okay? So first thing I'm going to do is I'm going to get x squared by itself. So I'm going to get rid of positive 81 by subtracting. So x squared equals negative 81. To undo a square, you're going to square root both sides. So the square root of x squared is x. And then I'm going to separate this. This is going to become 81 times the square root of negative 1. The square root of 81 is 9. The square root of negative 1 is I. So last year you would have said this answer is no solution. This year you say you do have two solutions, they're just imaginary. Plus and minus 9i. Number 2, same thing. I'm going to get rid of the plus 9 first. So 2x squared equals negative 8. Then I'm going to get rid of the 2 by dividing. So x squared equals negative 4. So I'm gonna get rid of a square by square rooting. So x equals, I'm gonna change this to 4 times the square root of negative 1. The square root of 4 is plus or minus 2. The square root of negative 1 is I. My answer is plus or minus 2i. Okay. Let's do a couple more examples and then we'll be done. So number 3, I'm going to get rid of the plus 15 by subtracting. So I got 4x squared equals negative 24. I'm going to get rid of the 4 by dividing. So I have x squared equals negative 6. I'm going to take the square root of both sides. So x equals square root of 6 times the square root of negative 1. Unfortunately, there's not a perfect square that 6 is divisible by. So it's just going to stay like this. Okay, this one's going to be a little weird. I kind of need some more room. So remember I said the I is going to go in front of the radical. So this one is actually plus or minus I square root of 16. So square root of 6. Alright, number 4. I'm going to get rid of the 13 by subtracting. So I got x squared equals negative 14. I'm going to take the square root of both sides. So x equals square root of 14 times the square root of negative 1. There's not a perfect square that 14 is divisible by, so this is just going to be plus or minus I square root 14. Alright, so I want you to try these two. I know that number 6 has a big scary fraction. It works the same way as it always has. Just if you're using fractions in a calculator, put parentheses around it. So go ahead and try these. Okay, so here are your answers. I've worked it out step by step. If you got it wrong, then hopefully you can find your mistake and fix it, or you can contact me, and if you got it right, you're awesome. Alright, so go ahead and go to Haiku and try your assignment. Thanks.